Hello and welcome to this presentation on how to think like a scientist. And basically my objective for this content is to give you some of the basic tools, definitions, and nomenclature that will help you think and process information like a researcher. And this is essential for us as IO folks because an important part of our brand is how to think through problems in organizations from a logical, philosophical, and scientific perspective. This is going to set you apart from people who have MBAs or other kinds of business degrees. Not that one is better than the other, but in psychology, this is kind of the bread and butter and the undergirding of all that we do. And so I'm going to give you those tools now in the following segments here. And just know too that this is like learning a new language, and even at this point in the program, you may find yourself needing some more practice in this respect. So my goal is to screencast most if not all of the presentations for the class, and that way you can have them and review them at your leisure, rewind and listen as many times as you need. And in class then I won't be presenting it as I am here, but simply asking whether you have any questions, if you need me to elaborate on certain pieces, and also using the class for more applied problems and projects. So hopefully the goal will be more efficient use of class time and giving you the chance to absorb these things outside of class. And so in class we can really dig a little deeper. So I'll be going through this just as I would if I were in class, and please, jot down any questions you have to ask me in class when we meet together. All right, so what is the ultimate purpose of research? Well, the overarching objective that we want to do is to map our mental model onto reality as closely as possible. This is called the correspondence theory of truth, and in SCC, Schottish, Cook, and Campbell, they talk about the different theories of truth that are out there, and this correspondence one is the one that most closely matches what we do in science. Just as we wouldn't look into a circus mirror for an accurate depiction of how we actually appear physically, just as we wouldn't do that, we wouldn't use crappy tools to do our work. And so what we want is as solid of tools as possible when we go about our work. The whole point of research is to make accurate inferences. And that's going to be a term that you will see in SCC a lot. They talk about truthfulness of inferences, accuracy of inferences, validity of inferences, and those are all synonymous terms to mean how closely our conclusions align with reality. And so an inference is just simply a conclusion based on the findings of a study that we've conducted. Whether it be in the lab, we are manipulating something and watching the effect on participants, or we are introducing in an intervention or program in an organization, we're looking at if it's moving the dial on the outcomes we care about, as we would do in the program eval class. And so those are the things that we're going to be looking at more closely. Okay, so in making inferences, we want to make sure they're as accurate as possible. And there are certain ways that we can be accurate or inaccurate, and this is the grid that kind of summarizes this very nicely. So again, an inference just simply means a conclusion that we draw based on the available evidence that we have, typically from research studies that either we or others have conducted. So basically what we have is this 4 types of inferences that we can make. 2 are correct, which are in green here, and the other 2 are incorrect. Okay, so the first thing we'll look at is what our study has found. Our study can either find that there's a significant effect, maybe a correlation, regression, or an ANOVA, whatever stat technique you use, you find that there is some kind of effect in the data. So there's significance there. And then the other option, of course, is that we see no effect, and that just means that our ANOVA or regression was not statistically significant. The other thing that we need to keep in mind is this hypothetical part that we don't really have access to, and that is reality. We don't directly have access to, I should say. And that is what God only knows. And this is the objective reality that, of course, we don't know for sure. We just are trying to capture it as best we can by conducting our study. And in reality, there could be an effect. That means our intervention is working as intended in the org. The manipulation that we created is making participants answer a certain way on the DV. Or there could be no effect. In reality, our intervention is not effective. And so it's probably best to scrap it in this case. Now, I'm talking about this in the hypothetical. For each of these quadrants coming up, I'll just discuss them briefly, with the assumption that we know reality. But of course, we know that actually we do not know reality. So this is hypothetical. However, the reason that it's important to understand the hypothetical is that we can look at each of these and understand when we are in danger of falling into one of these, or if we have the fortune to fall into one of these categories. So we do have some tools for that, and by reason and by logic we can say, well, there's a high probability that we are in this quadrant, for instance, type 2, or there is a good chance that we are in type 1. So that's the idea. Okay, so let's take this first quadrant here, the correct inference, and that is when our study finds an effect, a statistically significant analysis. We ran that and it looks good, and in reality there is an effect, and so that is a correct inference, and this is the best cell to be in, right, because what you predicted actually happened. And you're accurate, and you're also have significance, so it's easier to publish those findings, which is great. People are more likely to kind of listen to you when this happens, I think. It's just a lot of good credence there to what you found. Conversely, let's say that you found an effect, and in reality, the program didn't work at all. All right, so that is type 1 error, and this is a false positive. This is an incorrect inference. And this is, again, in reality, this effect did not exist, and so, but we are saying that it did. And so, worst case scenario, you run a program that's very expensive, but it's not moving the dial on the outcomes, or it's not the program that's doing it, it's other things that, but you were fooled into thinking the program did that. And so that's the idea of confounds, and we've talked about that before. I'm sure you've heard it in previous classes, and if not, I'll give a quick refresher later in this presentation. All right, so that's of course incorrect, and then let's go on to the other incorrect one, and that's type 2 error. And this is when our study says that the findings are not significant, but in reality there is an effect of the program or the IV of interest. So this is the case where we just didn't pick it up in our study. And this is type 2 error, and this is pretty common in our field. Herman Aginis is a researcher in our field who is a stats stats expert, and he talks a lot about the ubiquity of type 2 basically in our field, that it happens a lot, and I think for logical reasons, or I should say logistical reasons. A lot of times we don't have precise measures to pick up what's there, especially if this is a small effect in the population. We won't be able to detect it unless we have really precise measures that don't have a lot of error, and we have random assignment, things like that, to make sure that we have this really good test. I guess RA is more pertinent to this one, but for type 2 it's going to be precision of measures, it's going to be range restriction, it's going to be other things that impact this one. So Herman Aginis says that basically what we have is a literature that is not picking up a lot of the things that are existing in reality. And so that's something to keep in mind, and I'm going to talk more about that in a second. All right, so the other quadrant is the last quadrant here, and that is that we found no effect, but there really wasn't one. So it's a correct inference, but it's kind of a bummer. It's just saying there wasn't anything to find, and of course we didn't find it, and so we have to go back to the drawing board to see if our theory, we can improve on that so we can conduct a new study. It's important to note that because of the way the publishing system works that we have in place now, if you are a practitioner and you're going to the literature to try to understand how to implement some kind of intervention in your org, or how to understand what predicts certain org behaviors, etc., you have to keep in mind that hardly any studies are published that show no effect, even if it is correct. Or regardless, incorrect or correct, it's good to know, it's good to have that study available so that we can see. However, what we typically only see in the literature are studies that found the effect that they were looking for, or they did some post hoc propositions to fit what their study was saying, their findings said. So the effect of that is we have an incomplete base of knowledge to draw from. And for practitioners, this really matters because we're making decisions about people and we don't have the full picture. This is something that a lot of people are talking about and trying to think about, but not a lot of concrete changes have been made yet to fix the issue. And fixing it would mean a couple of things at least. The first thing is that all studies that are conducted well but show no effect should be published so that they can be included in meta-analyses and can be integrated into the body of knowledge so that we have more accurate, a mass of information to draw from when we're making decisions. The other thing is that we need more replications. So even when we do get the results that we want, regardless of whether we do or we don't, we should be doing replications, because the more that the more times a study comes out with similar findings, the more credence and faith we can put in the results. Along those lines, I just wanted to briefly take a quick rabbit trail and show you a study that was conducted in the summer of 2015. And basically it was an initiative to replicate some of the major findings in social psychology. And it was done very systematically and done very well, to my knowledge. What they actually did is they took several of the studies and asked researchers to reproduce that study exactly the way the original person did it. I think it was 100 replications per study, so we could get enough replications to understand what was going on. And again, the reason that this matters is because in the literature right now, replications are hardly ever published. And the reason that a lot of people have surmised the reason that this is the case is because the way that our scientific culture is and the publishing culture operates right now is that new studies take precedence over studies that have already been done. So if you're simply replicating someone else's work, that's not novel and interesting enough. And journals sell by, of course, public interest and other researcher interest, and so if it's not interesting and novel, then they stand to lose profit. And so it's a whole system with lots of interlocking pieces that keep things going that probably shouldn't be going, and doesn't lend to accuracy in research, which is what we want. So I just want to show you this briefly. The results of this big initiative were that approximately 40% of the results were replicated. That means that they comported with the original results. And so that means that about 60% did not replicate, even with all of these measures taken to ensure that it was very much like the original study. And so when I think about replications and when I think about effects, well, it says a couple things to me. First, you can't put too much credence in any one research study, no matter how well conducted. And that's important for practitioners when you're looking at the research. Even meta-analyses are not panacea for the issue because um, meta-analyses don't publish, because there are no null findings out there usually, meta-analyses can't include those in their data set, and so you're only getting part of the picture there as well. The other thing it suggests to me is that with replications, it's more like a bell curve where you conduct a study over and over again and you have an average effect across all of those, and that would probably be the more accurate effect. Um, and what you can, so the whole point is when you do the certain thing in your organization, are you going to get a similar result as these other researchers did or other practitioners who did this study? And that's the idea, because when you're making judgment calls and decisions about people and orgs, you want to be as accurate as possible. So what do? You go to the literature to see what others have found and done. But if we're not reproducing those results, as this study suggests, very well, then what is the probability that whatever you implement in your org will work as intended and work like others have had it work for them? So ideally, it would be interesting to have some kind of stat analysis, and I haven't thought about this too much. It's just been recently that I've thought about this, that practitioners need some kind of guideline for looking at previous work and being able to apply it and extrapolate it to what they're doing in their orgs. And so if you think about replications as a bell curve where you have in the middle an average effect across all studies of this certain intervention, whatever it is, maybe it's a counseling technique if you're in clinical, maybe it's some kind of training if you're in an org setting. So you have a program and you want to know the chances it will work in your environment based on what others have done. And so again, you have all these replications, an average effect, and then you have a standard deviation or variance of that effect across all those studies, which is kind of like a confidence interval. And if it's really, really wide, then you know there's a lot of variability in its effectiveness. And if it's narrow, then you can count on the average as being the one that you can the average is more, I guess, reliable, you could say, or valid. And so those are some things that thinkers in the field are talking about and trying to figure out. But in the meantime, I just want you to have a grasp of the basic challenges of research and just know, here's, I guess, the summary of it all. When you go to the literature and you see an effect, I would say that you can estimate it as a little bit smaller than they're saying that it is in any given study or in a meta-analysis. So if you find an intervention in the literature that has a pretty large effect, if you implement it in your org, you may get a large effect, but it's more likely that you'll have a smaller effect than what the literature says. And so that's something that you can adjust your expectations to and adjust maybe your client's expectations as well. Just because of the way stats works, number one, we have regression to the mean effects, which we'll talk about later, but also the way that science and the publishing system currently operate, it's not as clear. It's not as clear as just taking a couple studies and saying, "Oh, here's some evidence, and it will work in my org as a result if we do this certain thing." Now, having said that, it's better than nothing. 2 studies are better than no evidence at all. So just because we can't do science perfectly or even satisfactorily sometimes doesn't mean it's not worth doing. So don't lose your faith in the process, but know that the process needs to be ongoing as well. So we need more replications. It's never finished. You can never say this is the way it is for all time. It's always dynamic, and as scientists we have to kind of keep going with the flow, keep changing our minds as new evidence comes to light, changing the way we do things in orgs, and not being afraid to do that, and just continue on with the tools that we have and doing the best that we can. Okay, so here's another big picture heuristic or model that I like to present that provides some basic, just the basic process of how we do research. And so in these kind of models, it is generally accepted that the circles represent the constructs, the abstract concepts that we don't have direct access to, like self-efficacy, org effectiveness, org productivity, job performance, and then all the constructs like individual different stuff like personality, etc. All these constructs that we think exist. And so what we do is we create measures and manipulations in order to operationalize them. Those are depicted as circles. And then the squares are the operational definitions of those. Okay, so we have here anxiety, and we're going to manipulate it in a certain way. We're going to expose people to a scary movie, for example, and make their anxiety go up. Or we will tell them that there is a big test coming up that's worth 60% of their grade or something. And that's kind of mean, but you get the point. And that may not always be ethical to raise people's anxieties in certain ways, right? And then we have the effect construct, which is performance on a complex task. So we could have someone do, we could operationally, we measure this in many different ways. We could ask them to do a lot of math problems. We could ask them to put together a puzzle of some kind. So there are many ways to capture this as well. We could observe their completion time on some kind of task. Okay, so internal validity is the truthfulness of the inference that our purported IV causes the DV. And so this arrow represents that causal flow. Causal arrows are always one. Once they're not double-headed, they're just one. They go in one direction, and this is the direction of the causal flow, such that anxiety is causing performance, not the other way around. Now, we could make an argument that there's a reciprocal relationship, that performance on a complex task is going to feed back into anxiety and have this circle, but for simplicity, we'll just do one way. So the construct validity that's represented by these arrows here that go from the construct to the operational definition. And construct validity is defined as the truthfulness of the inference that our operational definition closely reflects or accurately reflects the theoretical essence of the construct that we care about, that we're trying to measure or manipulate. Okay, so that's those. I think that's helpful for me when I think about internal validity versus construct validity. And then one more validity that is depicted here, and that is external validity. And external validity is the truthfulness of the inference that this causal relationship will hold up across different situations, across different people, across different settings, across different operationalizations of the constructs, for example. And that is represented by this arrow here. So let me give an example that might help elucidate this part here. So let's say, just as a hypothetical, you are going to manipulate anxiety in a certain way, and that way is that you have looked at the research and seen that one of people's biggest fears across, at least in the US, is that they fear public speaking. And so what you'll do to raise anxiety is tell your participants that they will come to the lab and they will have to address a crowd of people about a certain topic. And then you check their anxiety levels to see if your manipulation worked. Now, if we think about this carefully, and you may have already thought about that this aspect, and that is that there are certain people in the population who enjoy public speaking and they're very sociable. And they're not afraid of it at all. And so the manipulation will not work for those folks, and thus we will not see this correspondence for people who are highly sociable. So that is a boundary condition of the study. External validity means boundary conditions. And whenever anyone says boundary conditions, you can just remember that that means that um, these findings have boundaries. And once certain things are in place, the findings no longer hold up in certain settings. And for folks who are highly sociable, that won't work. We'll have to raise their anxiety in another method, using another method. And so this is an external validity matter in which this causal relationship will not hold up under any and all operationalizations of anxiety. Some it will hold up and others it won't. So I like to think of that as both a construct and external validity matter. All right, let's move along. The validity typology that SCC lay out is classic and everyone uses it in the field. It's the stat conclusion, internal, construct, and external. Just talk about them until they no longer feel awkward when you talk about them out loud. That's the goal. Please memorize these definitions. These definitions are extremely important. First, we have the stat conclusion validity one, and that just means that it just kind of assesses the truthfulness of inferences about the statistical connection between an IV and DV. So when we see, when we don't see it, this typically shows up with type 2 errors actually. So if we don't see the relationship we expected to see, why is that the case? Is it really true that these things aren't linked in reality? Or is it the case that they are and we just didn't pick it up because we didn't have precise enough measures to do so? Internal validity, that's the truthfulness of inferences that our proposed IV is causing the DV. Is that a causal relationship? And sometimes what happens with confounds is that we're fooled into thinking our intervention or our IV is causing something when in reality another variable is sneaking in and doing it and mimicking that effect. Construct validity, now this definition is worded a little differently than SCC because I think it's just easier, and this is the way I like to think about it. The truthfulness of inferences that our manipulations or measures accurately reflect the essence of a theoretical constructs that they're intended to capture or intended to manipulate. And finally, the external validity one is the truthfulness of inferences about whether this relationship holds across various people, settings, various measures, and ways of manipulating. All right, so one thing regarding external validity that I wanted to let you know, and I think I explained this in social psych as well, so maybe you heard this before, but there was a study done in 1975, Rosenthal and Roswell, very famous researchers, and they found that people who volunteer to be in research studies are systematically different in certain ways than people who don't volunteer. And so this has ramifications for external validity, as you can imagine. And that just means that there's this question as to whether we can extend any findings from our study to the population because the people who came into the study in the first place were different. Okay, so volunteers for research tend to be better educated, higher SES, socioeconomic status. They tend to be more intelligent, higher on need for social approval. Maybe they have trouble saying no, they like to please people. Hence, they said yes when you asked them. And finally, they tend to be more sociable and agreeable, I guess, than non-volunteers. And I believe this study has been updated a little more recently, at least in the 90s, and there were some similar findings. So the idea is basically that these are things we need to keep in mind when we're talking about research, and I even forget this one a lot, this idea that volunteers are different from non-volunteers. So even with all the great research we still have a lot of gaps, not only due to the publishing process as previously mentioned, but also with this volunteer issue as well. Okay, the research process pretty much looks like this. We have a theory of how the world works. Remember Fisk? She defined theory as a system of logical principles that we develop in order to explain phenomena that occur in the world. So we may, for example, believe that, um, you know, investing in people in certain ways like mentoring, training, coaching will impact org bottom line outcomes in some way. Or we have a theory that males and females will be treated differently in certain situations. Implicit bias may be working in certain places. So we have all of these theories to explain the world, and after we build them, we generate hypotheses about them, and we say, very explicitly, people who take this training will score higher on this skill than people who do not. So that's an example of a proposition or hypothesis. So in this class, you'll be going through these steps. You won't be actually analyzing the data, but just talking about how you would. And then you would be talking about what kinds of threats to validity could be impacting your study. All right, so from the hypotheses, you go to research design. You design a certain study to test those, collect the data, do your analyses, and then you see if the data comport with the original theory or if they don't. And if they do, that's great. You can publish the study and hopefully replicate it later. Other people or you can replicate your study. If the results do not comport with the theory, and this arrow here goes away, or you have this issue where you have maybe some parts of your data do comport with the theory and others don't, for example. That's happened to me a lot. Then you have to go through some modification and some interpretation and thinking about theory more and revising and refining and then making new hypotheses and doing this cycle again. So that is the goal. It is my personal belief that even if the results are inconclusive or even null altogether, that they just don't show anything, that they still should be published somewhere so that practitioners know that the work has been done and other researchers aren't in the position of doing the same study over and over again and it doesn't work. And so, because no one has published what didn't work. But anyway, but this is the tried and true kind of time-tested way that we do research in this cycle. And it's a cycle, like I said before, that never goes away. There's always more to do. All right, so inferential research. When we think about inferential stats or research, this is what we mean. Is first we define a population to which we wish to generalize the results. This could be children ages such and such to such and such. It could be women in the city of Seattle working part-time. You set that up beforehand and you make it as broad or as narrow as you wish. After that, you draw a representative sample from that population of a certain size, size n, and you run an experiment on the sample or collect data, analyze it, and then make inferences back to the population based on that data. So this is the inferential process. So in order to do this well, we need a sample that accurately reflects the characteristics of the population that we've defined. So if the population has 60% men and 40% women, or vice versa, that is the proportion that we want in our sample as well. If there are no children in our population, we don't, for our particular study, we don't want children in our population because we're not going to be generalizing to them, then no children should be in the sample either. So I'm not going to run the animation, but there's animation with this that you can do at your leisure. I didn't make the animation, someone else did. It was kind of cool, so I've kept it. But basically random sampling is that you randomly pull people from the population into the sample such that the sample is like a mini version of the population. And this is important for external validity because whatever we find in the sample, we want to have some kind of assurance that we would have found the same effects if we had had the whole population in our sample. All right, well, as you can see, probably have noticed, I have notes at the bottom of these slides that you can look at. They're notes for me that I use when I'm teaching, so I left them there for your use as well. Okay, so random sampling ensures external validity. Random assignment ensures internal validity. The definition of random assignment is that the only criteria for assignment to groups from the sample into the experimental group and into your control group is by chance. And that means no variable, no characteristic of these people here can predict where they go, which group they're assigned to. So this means that age, baseline skills, any skills that they come to the table with before they get into study, their personality, individual difference variables, all of those, none of those things can predict where they go. Okay, so that's random assignment. And basically what that means is that you have two groups that are equal in terms of variables that are both observed and unobserved. So variables that you have taken, collected from them, like IQ or personality, and so they'll be similar across groups, similar IQ, similar personality. And RA also ensures that any unobserved variables, anything that we haven't measured, will also be equalized across groups. So the only thing different will be the intervention, and it will be super clear, ideally, to pick up and to be able to see that in your stat analysis. Confounding variables confuse us as to whether it was our intervention that had an effect or if it was some other variable that we're not accounting for and didn't know about. So if we ask for volunteers to go into our training group, let's say we have a training on interpersonal skills of some kind, and we wish to know if that moves the dial on people's skills after they've gone through the training. And we ask for volunteers. So we say, we're conducting this voluntary training, please sign up. And then we take measures after the training on both those who signed up and those who did not. And voila, the people who went to the group have much higher outcomes. Does that mean it was the training that did it? Well, not necessarily, because the people who volunteered to go into the group may have been different in some systematic way than those who didn't, and those are the things that cause the effect. For example, people who are already sociable and agreeable and who have maybe fine people skills already are the ones who are attracted to going to training, so they're all going to go to this group. And then those who are more shy and just don't care as much, perhaps, or maybe they were too busy, etc. And those are the ones who are going to go, who are not going to sign up for the training. And so if we see differences later, how do we know if they're due to the program itself or to the characteristics of the people in the group or a combination of the two? And the answer is we do not know. So RA is a good way to fix that issue. So again, random sampling results in or yields strong external validity, whereas random assignment yields strong internal validity for our study. Okay, so I'll let you do this animation on your own, but basically what this animation shows is that in the previous slide with when we asked people for volunteers, certain kinds of people went into one group versus the other, but with RA, those people were evenly distributed across the groups. So any confounding variables were evenly distributed across the two groups, thus nullifying their effects in our stat analysis, making it clear, making the intervention easier to detect. So that's the goal. All right. The logic behind our research, modus tollens. Modus tollens is simply the name of this particular logic technique, and basically it was employed by Karl Popper. He lived several decades ago, a famous researcher, and he talked a lot about this idea of falsification. And he would say that for example, even if for thousands of years no one ever saw with their eyes anything but a white swan, we could never say that all swans are white. And the reason that we could not say that is because there's always a possibility that we're wrong. A black swan may be hidden somewhere, and even though no one has seen it, doesn't mean it doesn't exist. So if you were the person who said all swans are white and you were going to go to the mat for that, bet your life on it, you would be kind of, in a way, kind of narcissistic because you're basically saying there's no possibility that something can exist that I didn't see. And that doesn't make a lot of logical sense. And so in science and in life, I found this to be very helpful. And that is that any belief or assertion or inference that we make needs to be falsifiable. And that is that we specify the conditions under which we will reject our initial belief, whatever that is. All swans are white. What are the conditions under which we would reject that notion? Well, we would say we'd have to observe a black swan, and once we did that, we would know that all swans are not white. But we can never say all swans are white, regardless. Okay, so this is the beauty of falsification. If you have something in life that is very important, a belief that you absolutely want it to match reality, and this is important because the way that we take care of each other and the way that we take care of the world depends on our ability to be able to do this well. Maybe you have had people in your life who stuck to beliefs despite all contrary evidence, and you just wondered what will it take for them to even reconsider. I mean, forget overturn the belief, just even reconsider it. Is there any piece of evidence or combination of pieces that would turn you? And if so, what are they? And when can you be intellectually honest enough to say, okay, I'm going to have to revisit my cherished belief, whatever that is? All swans are white is just an example, of course. So for Popper, he would say a belief that is not falsifiable basically is not tenable, it's not logical, and you shouldn't be holding it because there's no way of knowing when you're wrong. There's no checks and balances. There's no way of aligning yourself with reality once again. And when you have a significant other, you know this, right? They're kind of maybe your check on reality, and they hopefully gently let you know when your belief is out of line, and you listen to them and allow them to overturn you. And that's what humility is, and that's what staying intellectually honest really means. All right, so in the scientific context, basically what this boils down to is we have two premises and then a conclusion. And this is called a syllogism. And a syllogism just means that we have premise 1 and premise 2. And given those, a conclusion naturally flows from that, assuming that these are both accurate. Okay, so in this case, if we have a certain condition, then this result follows. So if P, then Q, premise 1. Okay, and I'm going to go through an example here down below in a second. Let's say we have the reverse of Q. Then we can overturn P in that case, and that is our conclusion. Okay, so just a quick note on notation here. The tilde just means opposite of. So it's a reverse of something. Okay, so here's the example of the swans. If all swans are white, okay, so here's my belief for now, then I will not observe a black swan. Okay, so this is true, right? This premise doesn't seem to have any logical flaws. And the second premise is the opposite of Q. So the opposite of not observing is that you did. Okay, so not Q is that you observed one. Thus, you can conclude all swans are not white, opposite of P. Okay, so that is called the modus tollens and is the foundation of science. It is saying, again, we can never assume something is true. We can say, okay, here's maybe a qualifier. You can say this is true given the evidence that I have now, but here are the conditions under which I will revisit that. And that is, I observe a black swan. All right, so how does this relate to research? Hypothesis testing. Our assumption is the world is random. That is the null hypothesis. Nothing is related to anything. It doesn't matter how much training we give employees, they will still perform the same. Just there's nothing there. Okay? But we know the world isn't like this, but we're going to set up a falsification. That's why we do this. All right, so we're going to assume that everything is random, and we're going to falsify that. Okay? So that's the idea. So Popper's falsification idea here, we make an assumption about the state of the world if our theory is wrong, and then we attempt to overturn the assumption. That's the whole goal of science. So the first premise, if the world is random, that is P, then I will not find a systematic effect in my study. My ANOVA will not be significant. My t-test will not come out. My regression, it won't happen. That's Q. Now let's overturn Q. Overturning, I will not find a significant effect, is that you did. So I did find one, not Q. Then we can conclude the world is not random. And that's the way that we do science. Now please note that premise 2, if you found an effect, this could be wrong. Type 1 error can come into this. You may find an effect that isn't really there. Remember, that's type 1. So if that premise doesn't hold, then the conclusion will be wrong as a result. All right. So there's some assumptions with modus tollens here, and that is that the two premises are true. Then the conclusion will naturally follow and be accurate. But type 1 and type 2 can play a role in this, right? Type 1 can make you find an effect that doesn't exist. Type 2, you didn't find an effect. But that effect still did exist in reality. So premise 2, I don't think premise 1 is such a problem, but premise 2 can be a little bit vulnerable because of type 1 and type 2 errors. So think that through. Just keep mulling it over. All right, we are finally coming to the end. Necessities for inferring causality. Please know these three. I think we've gone over them before in various classes. But SCC give us these to give us a guideline for thinking through with our clients what's causing what. Okay, so the first one, cause must precede the effect in time. So the effect cannot come before the cause temporally. Now, interestingly, somebody made an argument in a book I was reading recently that if we have an omniscient being like God, if hypothetically that being could have the effect precede the cause in time because they can anticipate what you will do and put the effect into place before the cause comes. It was very interesting, but when we're dealing with mortals, it's always going to be the case that the cause comes first. All right, the cause must be correlated statistically with the effect. And finally, alternative explanations for the change in the DV are ruled out. So alternative explanations are things that, aside from your intervention, aside from your program, what are the other explanations that could be there? Like people in the training group were different somehow than the people in the control group, and so you were able to rule those out either with logic or with other variables that you collected to parse out, etc. So that's the idea behind that. Okay, so these are the three. Just a quick side note, cause must be correlated with the effect. Oops, I didn't mean to move that. Cancel. Okay, so the second premise, or the second one in this list, option in this list. There is some new thinking around this, that this does not necessarily have to hold up for causation to hold up. However, I don't want you to worry too much about that because it's a little technical. But for those of you interested, Little Rabbit Trail, Hayes, 2013, it's a book that's required for regression. In there, and this is Preacher and Hayes of moderated mediation. They kind of developed this whole technique. And Hayes says that basically what you can have is a cause and an effect, and you can have mediators that mediate or explain that effect in the middle, and they can be working in opposite directions from one another so that the net effect is going to be zero of the IV on the DV. Okay, so, and they didn't give any examples to my knowledge. It would be so cool to have a concrete example of that at work. But anyway, that's kind of the leading, something extra, kind of the leading thinking on this. So, but you're always safe to quote these and cite these in papers and on job interviews. In fact, a prior student of mine was actually asked this question on a job interview. I don't remember if it was for Best Buy. It was one of those, I think it was a big company. And and she went to SIOP and was interviewing, and they actually asked her, how do you know what causes what, basically? I don't know how they asked the question, but they were basically looking for these, and she absolutely blew them away with these and much more. And so with her response. So it's kind of a cool story, right? Okay, I just want to go over briefly Aristotle, the different causes that he theorized. What an incredible mind he had. When we're thinking about causation, Aristotle is the one to go to. So he developed 4 kinds of cause, and just for the sake of explanation, this is what we'll think about. Why does a particular painting exist, like a particular piece of art? And Aristotle would say that there is a material cause, formal cause, efficient cause, and final cause. So there's all kinds of causation. It's kind of neat. So he would say the material cause, the painting exists because the paint and the canvas that it, or whatever it was painted on, pre-existed, and this caused the painting. So somehow they pre-existed, they were there, and that's one cause. Formal cause is that the artist had to have the idea in his or her head before, and that's what caused this painting. Efficient cause, the artist performed the brush strokes and the different motor skills required to create this piece of artwork, and that's what caused the painting. And finally, final cause. I like this one best, actually, but it's the hardest to study scientifically, of course. The artist teleological or goal-driven overall purpose for the painting, and that is to create beauty and enjoyment for others. So that's the final cause, the most glorious, if you will, and grand cause for this piece of art. And so when you think about a program, why does this program exist, or why is it moving the dial on outcomes? There are certain things, I mean, this isn't super practical in this respect, except for the efficient cause, I would say, is the one that I want you to think about for this class, and that is, what are the different activities that are causing this program to move the dial on the outcome, okay? So in science, we tend to be concerned more with efficient cause than these other causes, even though they're very fascinating. I guess material cause is more of the physical sciences. All right, so causality is something that is much more difficult than I think we like to think it is. It's not clear at all, and it's something that we never know for sure. So even the things that we're 100% sure of what causes what, there's so much internal. For example, somebody was talking about when you flip a light switch, we know that that causes the light to come on, but all the mediating mechanisms in between and how it actually does that, more of these causes here. We have no idea, most of us, unless we're electricians. Same thing with driving a car, etc. And so causation is like really deep, and I like that. It's fascinating, and we'll never know it all for sure. David Hume was a philosopher who talked a lot about this, And he basically said, even the things that we think we know for sure of what causes what, um, that there's not really a good way to know for sure. And SCC talks about this as well. They say um, these two, the first two on this list, can be pretty easily identified for the most part and verified. But the third one, ruling out alternative, so let's say you find out this program works as intended, it's beautiful, everyone's happy. You will never know if it was something else unless you had RA, and even then we can quibble about it, but RA does help, but nothing is certain. So I think it's, I mean, not to discourage us at all with science, but just to say that it keeps us humble, that we don't know anything for sure, and it keeps us open to changing our minds if need be. And I think that's extremely important skill for practitioners to have, is the humility and the courage to change our mind as new information comes to light. And I think even if that causes short-term problems with a client, it builds trust. And so it's really important, and it's a hallmark of following the evidence wherever it goes, as a true scientist would. All right, well, this concludes this presentation. Thank you for listening, and I hope this has been helpful as you think about taking on more of the language and the thinking process of a scientist.